All right, we're going to go through worksheet 31, this study guide here, to make sure that you are as prepared as possible for our test on Monday. Again, just like always, you can use any notes, any purple worksheets that you have, all of your resources, this study guide on the test, so hopefully it won't be too bad. So, number one, starting out with some dilation stuff. That's how we started out Unit 2. Number one says triangle C prime, D prime, E prime is a dilation of triangle C, D, E. Write the coordinates for these 2 points. So point E, I can see is right here, and point E prime is right there. So E's coordinates would be from the origin 2, 1, and E prime would be 4, 2. Now I have to identify the scale factor of the dilation. Well, if this little guy is my first triangle and this big guy is my second triangle, we obviously got larger. We enlarged our shape. So I know my scale factor has to be greater than 1. It's not going to be something like 1/2 or 1/3. And to figure this out, all I have to do is look at the points. 2 times what equals 4? 1 times what equals 2? Well, obviously the answer to that would be 2. We got twice as big because my coordinates in each point got twice as big as well. That's number one. Number two, the triangles shown are similar. Identify their corresponding sides and corresponding angles. This one had a couple people tripped up. It's basically like one of those matching games where you have the cards flipped over and you flip 1 and 2 and you have to try and match them up and remember. It's kind of like that. So if I look at these 2 triangles, right, I see I've got X, Y, Z, and X, Y, and Z are all denoted or marked in a different way. X has a single arc, Z has a double arc, and Y has no arc at all. If I want to find the corresponding angles that are congruent, I just have to match up which angles have the same markers. Angle X has a single arc, so does angle C, so I know that angle X is congruent to angle C. Angle Y has no marker, just like angle A, so angle Y is congruent to angle A. Angle Z has a double marker, just like angle B, so angle Z is congruent to angle B, just like that. Now with side lengths, we have a little bit more we have to think about because we have to think about the order of the letters. But we can use the angle markers to figure it out. The first one, segment XY, so X, oops, wrong way, XY here, right, is the side length going from the single arc to the blank angle. So single arc to no arc. So I'm going to go down here. From my single arc to my no arc is from C to A. So segment XY is congruent to segment CA. All right. If we were to say AC, that would be wrong. My letters have to be in the corresponding spots of the name of our segment in the same way they're in the corresponding spots of my triangle. Look at YZ. I go from blank angle to the double angle. Blank angle to the double angle is from A to B, A, B. ZX goes from the double marker to the single marker. Double marker to the single marker is B, C. All right? Something that could kind of help us out with this is, look, X is congruent to C, Y is congruent to A, so XY is the same as CA. We kind of just substitute in these letters just like that. Z is congruent to B, X is congruent to C, so ZX is congruent to BC, right? It should all match up nice and perfectly. Hopefully that makes some sense. Number 3. So we got 2 pictures here. They're already split up. We don't have to split them up. We talked about this in triangles in a real world, that lesson. A 6-foot tall person is casting a 9-foot long shadow. Here's the person. They are 6 feet tall, and their shadow is 9 feet tall. At the same time, a tree is casting a 36-foot long shadow. Label the image, we just did, and find out how tall is the tree. So I know 3 pieces of information. I just labeled them. I don't know how tall the tree is, so we're going to call that X. All right? What I want to do now is set up a proportion. All right? There's a couple different ways, There's a couple different ways we can set this up, like we talked about. I'm going to do big height over little height equals big base over little base. It's just the easiest way to do it. Big height over little height equals big base over little base. I should see that my big triangles across the top, my small triangles across the bottom. That's what I want to see. And now I'm going to cross multiply. X times 9 is 9x. And 6 times 36, we plug that in our calculator and we get 216. All right, that's cross multiplying. I multiply the numbers across like 2 Band-Aids over a wound, I guess. If I want to get x all by itself here, I got to divide both sides by 9 to get those to cancel. And 9 goes into 216 24 times. Now x equals 24 is great, but we're missing one little thing, and that is my units, which in this case are feet. So we find by doing this process that my tree is 24 feet tall. If you remember, there's a little trick we can use to check our work here, right? Base to base, 9 to 36 is times 4, right? 9 times 4 is 36. 6 to 24 is also times 4. So I know that I did this right for sure. If I get something that's off, not proportional, then I know that I did not do it correctly. All right? Number 4 is a lot like our warm-up from Thursday, because it is our warm-up from Thursday. Here's my pre-image with all those coordinates. I'm going to dilate it by a scale factor of 1/2. When my scale factor is less than 1, I know that I'm getting smaller. So my new rectangle should fit just inside this big one. And I got to find my coordinates. Well, to find my prime coordinates, I got to multiply my pre-image coordinates by the scale factor of 1/2. So all of these guys get multiplied by 1/2. Like we've talked about, multiplying by 1/2, I'm going to write it down here. Multiplying by 1/2 is the same as dividing by 2. I just cut all these numbers in half. So half of -8 is -4. Half of 10 is 5. Or I could think 6 divided by 2 is 3. 10 divided by 2 is 5. -8 divided by 2 is -4. I'll double that up for t prime. Half of 6 is 3. And half of -8 is -4. Now I have to plot the points. Graph the image means plot the points. So r prime is at -4, +5. S prime is at +3, +5. T prime is at -4, -4. And U prime is at 3, -4. Connect those all up to make my little rectangle. I definitely did get smaller there, so I feel pretty confident I did that right. Now, what are the lengths of the following sides? Okay, to find the lengths, I just got to count the units. SU. Here's S, there's U. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18 units long. right? And RS, here's R, there's S. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 units long, right? Now my dilation here is by 1/2. So not only did my points get cut in half, but if we count, we'll see that our lengths got cut in half as well. S prime U prime is 1, 2, 3, 4, 5, 6, 7, 8, 9 units long. And R prime S prime is 1, 2, 3, 4, 5, 6, 7 units long. I can't even count anymore without hearing 6, 7. My life is ruined. Those are what I get. Those are what I get. 18 and 9, 14 and 7. Clearly, I multiplied my side lengths by 1/2, and we can see that in the way we counted, which means we definitely got that right, and we're good to go. All right? Front side, hopefully not too bad. Let's take a look at the back. Number 6, nice and easy. Triangle XYZ has vertices, which is just points. Right? Vertices just means points. At these, well, points. If the triangle is dilated by a scale factor of 3, what are the new image coordinates? Well, when I have a scale factor like 3, again, all I got to do is multiply all my coordinates by that number, which in this case is 3. So 0 times 3 is 0, 1 times 3 is 3, 4 times 3 is 12, negative 2 times 3 is negative 6, negative 3 times 3 is negative 9, and negative 3 times 3 is negative 9. Boom. Easy. Just multiplication. Number 7 is the triangle sum theorem. This is what we talked about. All triangles, no matter what they look like, are going to add together. Their interior angles, I should say, are going to add together and equal 180. So if I know that A is 55 and C is 70, all I got to do is find B. Right? I'm going to add these together. I get 125 plus B equals 180. And then I'm going to subtract 125 from both sides. Those go away, leaving me with, what is that, 55 degrees. Don't forget the degrees. That's going to be a dumb reason to get a point taken off, because you got 55, you did all the math right, but you didn't write your units. If I'm asking for a measure of angle B, my answer has to have degrees on it. Has to, if we want full credit. Okay? Along the same lines as that, I could also use the triangle sum theorem to determine if two triangles are similar or not. Remember, similar just means same shape, but they might be different sizes. Okay, clearly these guys are different sizes. Let's figure out if they're the same shape. If they are the same shape, they should have the same angle measures. I see one of them is already the same, 80 and 80. But I need to find two that are the same. So either this one has to be 35 or this one has to be 50. It does not matter which triangle I use. I could use the big one or the small one. Let's use the big one here. I'll set this up. 80 plus 50 plus, we don't know, Z equals 180. 80 plus 50 is 130. If I want to get Z by itself, I got to subtract 130 from both sides. And that leaves me with Z equals 50 degrees. So this guy up here is 50. All I got to see now is, does that match my corresponding angle in the small triangle? Well, 50 and 35 clearly don't match. So these triangles are not similar. If we found that Z equals 35 degrees, then we could say, okay, these are definitely similar. All right? Not similar. I feel like we're pretty good with that one. It was the most recent thing we did, so hopefully it's not too bad. Number 9 gives me a hint to split the picture into 2 triangles. That's definitely going to help us out. Let's do that. I got a big triangle and a small. If I look at just the small triangle, right, that's this guy right here. My height is x and my base is 4. If I look at my big triangle, right, if I see this big guy here, the height is 9, but the base, I have to combine these guys together. 8 plus 4 gives me a base of 12. Okay? I have to combine those bases together. Now, just like we did on the front, I can set up a proportion here. Big height over little height equals big base over little base. And then I can cross multiply. On this side, I get 12 times x. On the other side, I get 9 times 4. 12 times x obviously is just 12x. And 9 times 4 is 36. Once again, if I want to get x all by itself, I'm going to divide both sides by 12, leaving me with x equals 3 feet. Don't forget the feet. Okay? Or meters or centimeters or whatever the units are in the problem, it'll always tell you feet, feet, feet. My answer has to be in feet as well. Really, really important we do that. All right. Number 10 is a beast. Look at all that. But it's actually really easy as long as we know how to count. Use the coordinate plane to find the lengths of sides. Lengths of sides. Just like we did over here, we're just going to be counting how long the sides are because they're on a coordinate plane. Starting with DEF. DEF. Triangle 1. Okay. DE is 2 units long. DF is 2 units long as well. Pretty easy. I can count. Let's look at my second triangle, my bigger triangle, my result of a dilation, triangle 2. D prime E prime is 1, 2, 3, 4 units long. And D prime F prime is 1, 2, 3, 4 units long as well. Now it says to find the ratios of the corresponding sides. Okay? D prime E prime is 4 units over DE, which is 2 units. Well, what is 4 divided by 2? 2. Same thing over here. D prime F prime is 4 units. DF is just 2 units. And 4 divided by 2 is once again 2. So because these ratios work, the question, is triangle D prime E prime F prime a dilation of triangle DEF? Yes. It definitely is. Is it a growth or a shrink? Did I get bigger or smaller? Well, I went from 2 units to 4. Clearly, I got bigger, so that's a growth. What's the scale factor? How much bigger did I get? Well, that's what we just solved for right here. I got twice as big. Okay? Now, this dilation looks a little bit weirder than the ones that we've seen, because it's not directly over the origin. It's like we took this guy, grabbed the corner, and we dragged it up, expanded it, made it a lot bigger, twice as big to be exact. But that's how we would do something like number 10. Okay? Hopefully that helps give you an idea of what to expect on the test we are taking on Monday. Remember, all of your purple assignments, A15, A16, they're all due no later than Monday when our class period is over. All right? Feel free to watch this video this weekend to get yourself all caught up and ready to go for Monday.